And we're going to use an equation that we've talked about in the past. So we'll see if we remember that. So we're going to use some of the techniques that we talked about on the front page. Okay? And if you guys want this page here, we're doing that tomorrow. So this is 5.5, day 2. So don't worry. We definitely will not do that today. Alright, so for this problem, we have a jet. It is going from Chicago to London, and it is traveling 3,950 miles from Chicago to London. Okay, and it's the same amount of miles on the return trip. Okay, same route, same amount of miles. The total flying time is 16 and a half hours. So the total flying time, 16 and a half. Okay? That's there and back. I don't know if that's accurate, but I think it is. Are you guys flown to England? Yeah, I think it is. I flew to Sweden. It was like 8 hours. So, 16 and a half hours is the round trip. Now, the return trip takes longer due to winds that generally blow from the west to the east. And the jet's average speed with no wind is 485 miles per hour. So if you're not counting the wind in that, it's the 485 miles per hour. Okay? What we have to do is find the average speed of the wind during the round trip flight. And then round your answer to the nearest mile per hour. So that would be the nearest whole number. Okay? Alright, so to do a problem like this, the first thing you want to do is understand what the question is that you're trying to answer. So we talked about the plane and we've talked about the wind. We're trying to find what is the average speed of what?
Of the plane?
No. Yeah. And so that's a common misconception, is a lot of times you do want to find it of the plane. Are you going to be in physics this year? No? Okay. When you go to physics, and even next year in pre-calc, we do a lot of airplane problems in there, where you talk about the speed of the airplane and the wind. I like to think of it as, you know, if you've ever ran outside, right? The wind's at your back, you're like, yeah, this is good, it's helping you. But if you're running against the wind and it's pushing against you, right, it slows you down a little bit. And the key here is we're talking about the round trip flight. So we're not just talking about one way. We want to know what it is during the round trip flight. So when I see a problem like this in my textbook, I like to organize by information. I feel like that gives me a solid start and prevents me from reading the same question over and over again. So I'm going to list important information. So they do tell you the distance. Okay, the distance one way is 3950. And they do tell you that that's each way. So if it's 3950 each way, what's the total distance? Here's a simple way to do it. What could we round this up to? 4,000. Yep, okay. 4,000 plus 4,000 is 8,000. And then you could just subtract 50 twice, which would be minus 100. Okay, so that would be the total distance in miles. All right, they also talk about the average speed of the jet without the wind is 485 miles per hour. equation that they give you. Yes. Yep, and that's the total amount of time. Okay, so the total time is 16 and a half hours. Okay, so together we're going to make a plan. Notice that we have the distance, the speed, and the time. Do you guys remember that special equation we talked about earlier? Starts with D. D equals distance equals the what times what? Right? Yeah, which is the speed times the time. D equals RT. Okay, so we're going to use this to help us. The first thing we have to do is we have to make sure we're representing the wind here. So we're going to call W the speed of the wind. Okay, so we're going to call W the speed of the wind. So the distance in miles, we're organizing this in terms of the to and from, and really I should have put one more on there, but I'm just gonna write it in, is the total at the bottom. Okay? So we know that the distance, D, to London is 3950. From London is 3950. So the total distance is 7,900 in miles. Okay. Now, the average speed of the jet without the wind is 485 miles per hour. And that is going to be your total for the average speed. And this is where I'm going to help you fill this in. Okay? So, in the problem, it implicates on one way the speed of the wind is helping the plane, and the other way it is not helping the plane. So the way that we're going to represent this is, for the rate on the way to London, we're going to call this 485 plus the wind. But on the way back, it's 485 minus the wind. And the reason why, I'll do the second one. The reason why the way back is the minus the wind is because it's working against it. Okay? Let's just say the wind was 20 miles an hour. If you were to subtract it, then your average speed would be 465. So do you see how that would be less? So that's why you have to do the minus here. Okay? Now, to get the total, you would just add those together, divide by 2. If you add those together, it would be 485 times 2. You divide by 2, you get this. This is something that's going to be standard for all your problems. Okay? Now the last one, we're actually going to calculate. So the time t, right now, all we know about the time is that it's 16 and a half hours. But we have this equation. If the distance equals the rate times the time, then the time is going to equal, how would you get t by itself? Divide both sides by r. So then the time is calculated by doing the distance divided by the rate. So that's exactly what we're going to do for this box. Okay, so we're just going to look at the first row. So the time to London is calculated by this. We do the distance, which is 3950, divided by the rate. And the rate is 485 plus W. So we're going to leave it as that expression. Based on that, do you guys think you could write this step here? So again, we're just doing the distance divided by the rate. So in this row, your distance is here. So 3950 divided by 485 minus W. Okay, and then this is the column that we are going to work with to solve. So the step 3, the solving, what we're going to do is we are going to set up an equation with the time information, and we're going to solve for W, because that's what we want to find, is the speed of the wind. The time equation is just going to be simply the trip to London plus the trip from London equals the total amount of time. So your equation is just 3950 over 485 plus W plus 3950 over 485 minus W equals 16.5. I know that seems kind of complicated, and solving it isn't going to be simple, but this process here is just very similar to the distance, right? Remember, 3950 plus 3950 equals the 7900. We're just going to have to solve this, but that's where it comes from. The time it takes on the way there plus the time it takes on the way back is going to be equal to 16 and a half hours. So to solve this for W, we're going to use the same skills that we did before. So we just have to find the LCD, and then we're going to multiply each side by the LCD. What is the LCD? Yeah, so just start on the bottom. So the LCD has to be 485 plus W, and then it has to be 485 minus W. So we're going to multiply both sides by the LCD. And we're going to give ourselves some room for that over here. Okay, so if I multiply this by this, we're going to write small, okay? So it's 485 plus W times 485 minus W times 3950 over 485 plus W plus, so I'm doing the distributing first this time. And this is the 485 plus W times the 485 minus W times the 3950 over 485 minus W. So do you guys see that I'm just multiplying each part of this equation by the LCD? So the last one is the 16.5. Should have color coded that one. And that's going to be times 485 plus W, 485 minus W. So this is exactly like what we were doing on the front page. And yep, you're going to want your calculator for this. You can definitely use your calculator. But you are going to have a lot of cancellations here. Don't FOIL this out here. What's going to cancel?
45.
Yep. So those are going to cancel. What you're going to multiply is the 485 minus W times the 3950. And then this is going to be plus. The minus W's are going to cancel here. So you have 485 plus W times 3950. And then for this one, you're going to have 16 and a half times, nothing cancels out here. So you are going to have to do what with these two? FOIL. But these are the difference of two squares here. Right? So you have 45 plus W, 45 minus W. So we just have to multiply 485 times 485. And this becomes 235, 225 minus W squared. Okay, so you do have some larger numbers there, so I'm going to give you a minute to calculate. So you're just going to distribute, 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 distribute. So I'll give you a minute to do that calculation. Alright, so you were on the right track if you got 1,915,750. How'd we do with that? Anybody want to go into finance? Yeah, working with the, did you say you wanted to go into finance? Yeah, yeah. Nobody in my other hours that they wanted to. I was going to say, this is a good problem to get you exposed to some of the larger values. Though you will be working with spreadsheets a lot. And really, what is the nice thing that happened on this side when you combine your like terms? Yeah, the W terms canceled out. And really, this guy is just going to double. Okay? And then on the other side, when you distribute, should have got 3,881,212.5 minus 16.5 W squared. Okay, so when you add these two together, you get 3,831,500 equals 1,881,212.5 minus W squared. So I know these are big numbers to write out, so I'm going to show you the shortcut. So we just do minus this guy minus this guy equals negative W squared. So then let's just put that in our calculator, okay? So we have 3,831 500 minus 3,881 212.5. Okay, so negative 49,712.5. Is that what you guys got? Oh, my bad. No, I dropped my negative 16.5. Why don't you guys tell me? So keep that there from that step to that step. And then we're going to divide by negative 16.5. So when you divide that by negative 16.5, okay, you get this decimal, and you have W squared. So how are you going to solve this? Take the square root. Now when you take the square root, your answers are plus or minus, but when you're talking about the speed can't be negative. So it's 54.8 dot dot dot. So this is going to be rounded up. So the speed of the wind is approximately 55 miles per hour. Right? So, I mean, that's a pretty big wind. So again, just remember, you're throwing out the negative because the speed can't be negative. So you can throw out that answer that doesn't make sense. is, does your answer make sense in terms of the problem? Okay, does your solution make sense? Okay, so for the W, you could plug that back in. You could make sure that all of those were equal. Okay, and you do have something that's reasonable. So when I say making sure it makes sense, if you got the wind was going 400 miles an hour, that's outrageous. Okay, so that's the speed of the plane. It's not going to be going as fast as the plane. Okay, all right, and then we're going to stop there for today, and we'll do the last problem and the inequalities tomorrow.